Hello students, welcome to my class on operating system. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Today I will discuss process synchronization. So after this class you will be understand what is the need of the process synchronization and what problem we can solve with the help of the process synchronization. Now, before going to the details of the process synchronization, let us understand, let us discuss a very simple problem. And that will help you to understand why we need the process synchronization. Fine. So far, you know that the processes can be are of different types. Fine. So all the processes can be classified into two categories. First one is the cooperating process and the second one is autonomous process. Okay. Cooperating processes are those processes which needs to exchange some data item among themselves. Fine. And autonomous processes are those processes which are self-sufficient. That means each process is self-sufficient and the execution of a process is not dependent on other. So let us say P1 is a process and P2 is another process. So what happened over here, that execution in case of autonomous process, the execution of P1 is not dependent on execution of P2. So they both are not dependent, they both are not dependent on each other. Whereas if P1 and P2 are the cooperating processes, in that case P1 needs to communicate with P2 or they needs to exchange some data item. Fine. Now let us, so this synchronization problem, so which we are discussing today, the synchronization is a problem which is mainly for the cooperating process. Fine. So synchronization is required for cooperating, for the execution of the cooperating process. Fine. Now what is that, what is this problem? Say P1 is a process and P2 is another process. Now both the processes P1 and P2 are using a common variable, say counter. Okay, so counter is a common variable which is used by both the processes P1 and P2. Fine. Now let us say that inside P1 there are some set of instruction, and apart from that there is another instruction which is called like counter plus plus. Whereas inside P2 again there are some set of instructions, and apart from that there is another instruction, let us say counter minus minus. Fine. So both P1 and P2, both processes are sharing a common variable which is called counter. Now let us say that for in some instance the value of the counter variable is 5. Now if P1 execute first and then P2 execute, that means in this time series the P1 execute first and then P2. So what will happen? What will be the, after execution of P1 and P2, what will be the value of the counter? So you can see the counter for the process P1, it is increasing the counter. So what is the counter plus plus? This statement is nothing but counter equals to counter plus 1. Whereas this statement counter minus minus is nothing but counter is equals to counter minus 1. So what the process has to do? The process P1 has to read the value of the counter first, then increase it by 1 and then again rewrite the new value in the variable counter, in the memory space of counter. The same operation should be performed by the P2. It has to read the value of the counter from the memory location, then decrease it by 1, and then rewrite the decreased value, new value inside the memory space. So if P1 execute first and then P2, then what will be the value, ultimate value of the counter? So in this case, initial value is 5. So P1 will read 5 and then it will read 5, then it will perform this operation 5 plus 1, that is it will perform the operation 6, and then the value of the counter will be increased, changed by 6. Fine. Now after that P2 will perform the operations and P2 will execute counter minus minus. So what will happen? It will read the value 6 from this memory location and then perform this operation 6 minus 1, that is 5. That means after performing after execution of P1 and P2, at this point the value of the counter is again remain 5. Okay. Now let us execute the same process sequence in another way. Consider P2 is executed first and then P1 in our timeline. Fine. So if P2 execute first and then P1, then what will happen? Consider the same value of the counter. Fine. So the counter is initialized to the variable, to the value 5. So let us write 5. Now what will happen? P2 will execute first. So if P2 will execute first, it will read 5 and then it will decrease it by 1. That means it will perform 5 minus 1. So answer will be 4. So 5 will be replaced by 4. Then P1 will read the same value. So it will read 4. It will perform the increment operation 4 plus 1 and answer is 5. So 4 will be replaced by 5. So at the end of the P1, at this point, what is the value of the counter? The value of the counter is 5. Fine. So you can see that if the processes P1 and P2 execute in sequential manner, then the value of the counter should be 5. Now, in case of cooperating processes, the processes can execute parallelly. Fine. That means with P1, P2 will also execute parallelly. So if it is so, that means if P1 and P2 both are executing parallelly, in that case what will happen? Fine. So P1 will execute first and then P2. So in that case, the P1 and P2, let us write down the sequence like this one. There are some set of instructions of the P1. Then P1 will perform the operation read counter, because you can see that counter plus plus is nothing but a three group of operation. Okay, before that I should write down this counter plus plus. Counter plus plus is nothing but a set of operations, which are, first one is read counter, then counter is equals to counter plus 1, then they perform the counter plus 1, then the write operation will be performed, that is write counter. So this is a three set of operations which will be performed for the counter plus plus. Similarly, if we want to perform the counter minus minus, in that case, first we have to read the counter value. So we will read counter, then counter minus 1, and then we have to write down the new changed value of the counter. Okay. Now, if P1 and P2 execute parallelly, then what will happen? So read counter, then counter plus 1, then write counter. Okay. Similarly, in case of P2, the instructions are like this one: read counter. Before that, there are some set of statements. Then counter minus 1, and then write counter. Okay. So let us say the initial value of the counter is 5. Same value. which we considered in case of sequential execution. Now we are considering the parallel execution of P1 and P2. So what will happen? Assume that at time step T1, the process P1 will read counter. Fine. And at time step T2, the process P2 will perform this operation read counter. At time T3, it will perform counter plus 1. At time T4, it will perform counter minus 1. At time T5, it will perform the write counter operation, and at time T6, the process P2 will perform the write counter operation. So there are 6 timestamps, and in different timestamp, different operation will be performed. Okay. So what will happen over here? First, let us assume at time T1, the P1 will read the value of the counter. So that means it will read the value 5. So let us write it over here. It will read 5. Fine. Now at time T2, P2 process will read the same value of the counter. So it will also read 5. Okay. Now next time instance, that means at time T3, the process P1 will perform counter plus 1. So it will perform the operation, it will compute 6. But next in time instance, the P2 will compute the value counter minus 1. That means it will compute 4. Now at time T5, the P1 will write the value of the counter. So it will write 6 at this place. Now in the next time, the process P2 will write the value of the counter in the same memory location. So it will overwrite the 6, it will write down 4. So the correct value should be 5, but instead of 5, it is writing either 4 or 6. Similarly, if we change the execution sequence, that means if it is T5 and if it is T6, in that case, instead of 4, the value which will persist in that memory location, that is 6. So you can see that in the counter memory location, either 4 or 6 value will persist, where the actual value should be 5. Okay. So what will happen over here? In this case, there is a synchronization problem. And due to that synchronization problem, some data inconsistency will occur in the program. Data inconsistency means the invalid data will be stored inside the memory, which is not the correct. Incorrect data will be stored inside the memory. So what will happen? So in case of this multiple processes executing concurrently, we should implement some synchronization technique so that this data inconsistency will not occur. Okay. So this is the basic of the introduction of the synchronization problem. So you can understand that if 2 processes or more than 2 processes are executing concurrently, in that case the synchronization, and if they share a common variable, that is a very important part. They share a common variable or common file or common resources where we need to perform the write operation, and which will, after performing the write operation, that the value of the resource will change. So in that case, the process, we need to take some extra measure so that the data inconsistency will not occur for the execution of those processes. So that's why we will execute different types of synchronization algorithms. So the different synchronization algorithm we will learn in this chapter. So based on the synchronization algorithm, the execution of the process can be controlled, and so that the variable will hold the correct value. Fine. So now we will discuss a very well-known problem, which is called the producer-consumer problem. And after discussing the producer-consumer problem, I will discuss how the synchronization technique will be applied to solve this problem. Okay. So we will start the producer-consumer problem. The problem we are discussing now is called producer consumer problem. Now, what is this producer consumer problem? In the producer consumer problem, there is two processes. Fine. Two processes. One is the producer process, another is consumer process. So, what are the two processes? The first one is the producer process, and the second one is the consumer process. Fine. So, now you can see that in case of producer process, the task is that the producer will produce some items, and after producing the item, it will store the item in some common storage. And the task of the consumer process is to consume the item which is produced by the producer from that common storage. Fine. So this is the main problem of the producer consumer problem. Okay, this is the main consideration of the producer consumer problem. So now we will write some program for the producer consumer problem. So what I told you, that the producer process will produce some item and the consumer process will consume that item. Fine. So let us write something, some code like, so assume that here the producer process will produce item I. Okay. After producing the item, what it will do? It will store it in some common memory place or common storage. So let us say that common storage is the buffer. So we will write it, name this common storage, which is called the buffer. Okay. Now, this buffer, this item I will be stored inside the buffer. After, so what we will do? We have to keep some common checking condition which will check whether the buffer is empty or not, because the producer will produce the item, and after producing the item, it should store the item inside the buffer. But if the buffer is not full, any empty space is available inside the buffer, in that case the producer process cannot store the item I inside the buffer. Okay, so we have to check. So we will write while counter is equals to buffer size. Now what is, right, buff size? Buff size is the buffer size. What is the counter? The counter is a variable which will keep track how many items produced by the producer. Fine. So it will count the number of items. Fine. Now, and what is the buff size? The buff size variable is the total free size of the buffer. That means the total size of the buffer is called the buff size. So what is buff size? It is a total size of buffer. Okay. Now, the thing is that while counter is equals to buff size, that means if the value of the counter is, that means the total number of item already produced is equals to the size of the buffer, that means that indicates all the items are, all the buffer space, all spaces are filled up by the item. So the item which is produced by the producer cannot be stored inside the buffer. So what we will do, we will put a semicolon after that while loop. So that is an infinite blocking. That means if the value of the counter is equals to buffer size, then the item cannot be stored inside the buffer. Otherwise, let us say the name of the array is the buffer. So otherwise, what will happen if this condition is not true, then the inside the buffer we will store the item. So we will write buffer in. So in is a pointer which points to that location where we have to store the item. So we will write buffer in equals to item I. Okay. So we will write down the item which is produced by the producer. Fine. Now what is in? In is a pointer. Indicate that where we have to store the item. Fine. Now next we have to increase the value of the in by 1. So we will write in equals to in plus 1. And then as one item is already produced and counter is keeping track that item is or the number of items produced by the producer or number of items present inside the buffer. So we should write down, we should increase the value of the counter also by 1. So that is a code of the producer process. Similarly, we also can write the code for the consumer process. So what is the task of the consumer? The consumer will consume the item. So what we have to write? We have to write while. So first, now there is a very interesting thing that when the consumer can consume the item, the consumer can consume the item if an item is present inside the buffer. So if the buffer is empty, in that case, the consumer cannot consume. So here we have to put a checking that if the value of the counter is equals to 0. Fine. If the value of the counter is equals to 0, 0 means the number, no item is present inside the buffer. So if the value of the counter is equals to 0, that means consumer cannot consume any item. Fine. Now, otherwise, the item consumed equals to buffer out. Again, out is a pointer which indicates the position from where we should consume. The consumer process will consume the item, and after doing so, we should increase the out pointer by 1. So we should write out equals to out plus 1, and then also we should decrease the value of the counter by 1 as the number of item or one item is removed from the buffer. So we should decrease the value of the counter as the counter keeps count the number of item present inside the buffer. Okay. So now we'll explain this problem. Suppose the total size of the buffer is 5. Okay. So we will draw a buffer with size 5. So item I1 will be produced by the producer and it will be stored. So initially the value, what is the value of the counter? Initially the value of the counter is 0. So I'm removing this part. Okay. So initially we'll write down the value of the variable. Initially the value of the counter is equals to 0. So the producer will produce an item I1 and it will be placed inside the buffer. So counter will be increased by 1. And in pointer is initially The value of the in pointer was 0. So now this is the 0th location. Let us write down 0, 1, 2, 3, 4. So in is 0. So counter is, while the counter is 0, 0 is, and what is the buff size? The buff size is 5. The buff size is equals to 5. So 0 equals to 5 will not satisfy. So we will put the item I1 which is produced by the producer in the buffer. So what is the value of the in? In is also 0. So buffer 0 is equals to I1. So we are placing the I1 inside the buffer 0. That is 0th position. And we should increase the value of the in by 1. So now in might become 1. And counter will also be 1. So counter is increased and it will now value of the counter is 1. Okay. Now producer will produce another item. So next item will be I2. So let us say how the item I2 will be placed. So next item will be I2. Again, what is the value of the counter? Value of the counter is 1. Buff size is 5. 1 equals to 5 will not be satisfied. So it will come out from the while loop. Then buff in. Buff in means buff of 1 is equals to item. So in the 1 place, the item I2 will be stored. And then in will be increased by 1. So in will be my 2 and counter will also be 2. Fine. Now again consider the producer will produce a third item I3. So while the producer will produce a third item I3, by following the same logic, I3 will be placed over here and the counter will be increased by 3 and the in position will also increase by 3. Now next, the consumer process. After producer process, the consumer process wants to consume the item from the buffer. So what will happen? It will try to consume. So first it will check whether the value of the counter is equals to 0 or not. So what is the value of the counter now? 3. Okay. So 3 equals to 0 will not satisfy. So it will come out from the while loop. So item consumed will be buff out. So what is the value of the out? Out will be initialized to 0. Okay. So buff of out will be buffer out is, that means buffer 0. So I1 will be consumed and I1 will be stored inside this variable item consumed. Now after consuming the item, the out will be increased by 1. So out will point to the next memory location. So out will value of the out will be 1. And the counter will be decreased by 1. So what will be the value of the counter? Now the value of the counter will now become 2 because the item I1 is already consumed by the consumer. So this is not present inside the memory location. Now let us say the producer will produce the fourth item. So after a while it will produce the fourth item. So I4 will be stored over here. Again the counter will be increased by 1. It will be 3. In will be increased by 1. It will be 4. And the producer will produce another item I5. So I5 will be stored over here. So it will be increased by 1. So counter value will be 4 and in value will be 5 and out is remain 1. Fine. So now the problem is that here one position is empty. Fine. But the value of the counter is 4. Buff size is 5. But the in position is 5. So we cannot place the item over here. So you can observe one thing. Instead of considering is a straight array, we should consider a straight list. We should consider it as a circular list, so that after storing the item in the fourth location, the in should come back to the 0th location. So only in equals to in plus 1 will not work. So what we have to write? We have to write in equals to in plus 1 mod buff size. So if you do so, you can see that after storing the item I5, one position is already empty. The 0th position is already empty. Fine. So if the producer process wants to produce the item, then what will happen? The producer, the item in will be, now in value of in is 5. So 5 plus 1 is 6. Fine. So okay, it will not be 5 rather. So it will not go 5 at this position, because while it is in the position 4, it will be 4 plus 1 5 mod 5. So after 4, the value will be converted to 0, so that the pointer will come back to the 0th position. So after 4, the value will be 0 if we convert the syntax, convert the statement by this way. The same thing is true for the out also. So we have to write not out plus 1, we have to write out mod buff size. Okay. So that when the out pointer will point the 4th location, after fetching the item 4th location, the out pointer will come back to the 0th location to check whether any item is present over there or not. Okay. So now, so in this way, the producer process and consumer process can produce and consume the item, and they can store inside the memory place or inside the storage which is specific or list which is specified over there. Now here, so far we have discussed the producer consumer problem here. So you can observe one important thing. We are executing either producer first, then the consumer, or producer 2-3 times producer, then 1 times consumer. So producer and consumer, these two processes are executing one after another in sequential manner. But in reality, the producer consumer problem can execute parallelly. That means the concurrent execution should be there. So if there is a concurrent execution, there are many common data items which is used by the producer and consumer. So mainly only for the data item counter plus, that means for the data item counter, the variable counter, the main problem, data inconsistency will occur while the producer and consumer process will execute parallelly. So I will explain this thing with the help of another example. Hope so far it is clear how the producer can produce the item and it will be stored inside the buffer, and how the consumer can consume the item from the buffer. Okay. Now I am explaining another example which will make you clear that why this counter plus and counter minus is playing an important role while the producer and consumer process will execute parallelly. Fine. So consider another buffer. This is called the buffer. 5 places 0, 1, 2. So let us say the size of the buffer is 4. Okay. And here in is 0, out is also initialized to 0, and the value of counter is also initialized to 0. So what will happen? Let us say the consumer will consume first. So while the consumer will try to consume, what is the value of the counter is now 0. So 0 equals to 0, infinite loop. Consumer cannot consume. But at this time, so now you should assume that producer and consumer both are executing parallelly, simultaneously. Fine. So now if the producer wants to produce, then what will happen? Producer it will produce an item I. Then after producing the item I, it has to store the item inside the buffer. So what is the value of the counter is now 0. 0 is equals to buff size. What is the buff size? Here buff size is 4. So I am writing over here. The buff size is equals to 4. I am writing it over here. So 0 is equals to 4 will not satisfy. Come out from the while loop. The item will be stored inside the buffer. So in is 0. You can see over here. So first item, let us say I1 will be stored over here. Now after storing the item I1 in that position, in will be increased by 1. So you can see in plus 1, 0 plus 1, 1 mod 4, output is 4. Output will be 1. So after performing this operation, the value of the in is 1. Now counter will be increased by 1. That means counter should become now 1. Okay? And as I discussed earlier, that the counter plus and counter minus has 3 steps. First is the read counter, perform the plus operation, store it. Read counter, perform the subtraction operation and store it. Fine. Now suppose another next in the way, now consumer wants to consume item and at the same time producer wants to produce an item. That means at the second iteration, second step, both consumer and producer want to produce and consume item. Producer wants to produce the item, consumer wants to consume item. What will happen over here? So in that case, you can see that let us say both are executing parallelly. So producer will produce the item. So the value of the counter is now 1. So 1 is equals to 4 will not satisfy. So it will come over here. Producer can produce and it will can store the item over here. So while the producer is at this stage, in that simultaneously the consumer start to execute the code. So what is the value of the counter is now 1. 1 is equals to 0. Fine, not satisfied, come out from over here, come out from the while loop. Item consume means buffer out is 0. So what the item it will consume? It will consume the item I1 from this location, and out will be increased by 1. Out will be 1. Fine. So, and here after execution in this statement, this particular statement, let us say the producer will also execute this in. So now my in will become 2. So both producer and consumer are successfully executed these two statements. In equals to in plus 1 mod buff size and out equals to out plus 1 mod buff size. And after executing these two statements successfully by both the processes, value of in is 2 and value of out is 1. Fine. Now what will happen? Now the producer and consumer both will execute this counter plus plus and counter minus minus parallelly. So both will read the value of the counter. So what the producer will producer will read the value of the counter is 1, and the consumer will read the value of the counter is 1. Okay. So what the producer will do? It will increase it by 2. Consumer will decrease it by 1, 0, and the producer will start. Now between producer and consumer there is a running. Fine. Race condition, racing. Who will store? We will store that item in that memory location first. So if the producer store the value of the counter in the memory location first, so it will store, it will make 1 as a 2 and it will store over here. And in the meantime, the consumer process will next store the value 0 in the counter place. So the 2 will be overwritten by 0. So finally 0 will sustain in the memory location. So between 2 and 0, any one of the value will sustain in the memory location, which is wrong basically. So you can observe that after consuming one item, the one item remain in the buffer. So this item I2 is remain present, one item is still remain in the buffer. So the actual value of the counter should be 1. Whereas instead of 1, either 2 or 0 is storing in the counter place. So that is a data inconsistency which is generated by the producer consumer problem due to the parallel execution of the common code section, which is common variable, which is called count. Okay. So now this problem can be solved, this producer consumer problem, this is called the synchronization problem due to the inaccurate synchronization, improper synchronization. This data inconsistency arises for the producer consumer problem. So what we have to do, we have to write down a proper algorithm so that when two processes has a common code section, common variable, which is where the right operation needs to be performed. So in that case, the common section should be executed by any one process. That means multiple process cannot execute the common section parallelly. Okay, so this is the basic logic for implementing the synchronization algorithms to solve all sort of synchronization problem. Fine. And there is another important concept is there, this common section. Okay, this counter plus plus or counter minus minus, whatever the operation, basically the operation which will need to be performed on the variable counter, that is called the common section. Whether it is a plus or minus, any operation, some writing operation needs to be performed on the place of the counter. So in that case, what will happen? This particular section has a special name. This section is called the critical section. So what is critical section? Critical section is a common code segment or variable or a segment where the writing operation will be performed in some file, and due to this writing operation by the multiple processes at the same time, some data inconsistency can be generated. So this particular section is called the critical section. So critical section is nothing but a variable or a set of instruction or a set of instruction which is used to write data item in some file or memory location. So that particular section is called the critical section. So if some common section is shared by both or multiple processes, in that case, the common section should be executed one by all the processes. That means here this common section is counter plus plus or counter minus minus. So the write operation, read write operation, which is performed on the variable counter, that is a common section, and that common section cannot be executed both the producer and consumer at the same time. Either the producer will execute first or the consumer will execute first. So if this condition can be imposed forcefully, so in that case, what will happen? My initial value of the counter was 1 at this second step. Before increasing or decreasing the value of the counter, the value of the counter was 1. So if we impose the condition that either the producer can execute first or the consumer can execute first, but both cannot execute parallelly, so what will happen? If the producer execute first, it will increase it by 1. That means it will be 2 and 2 will be written in the memory location, and then the consumer will execute perform the operation on the counter variable. So it will read 2 and decrease it by 1, and the 1 value will be stored in the memory location. So now you can see this 1 is a correct value which is stored inside the counter. Fine. So in this way, by imposing certain condition on this common section, we can handle the critical section problem. So that is all for today's lecture. In the next lecture, I will discuss the different algorithms, how to solve the critical section problem, synchronization problem, and what is the critical section and what are the race conditions. Those are the things I will discuss in my next class.